Chapter 2 is dealing strictly with proportional thinking. And before we can start talking about proportions, we first need to understand what a ratio is. Okay, so a ratio is a comparison of two quantities. And they can relate, they could not relate, but you're just comparing the two. And we really have three ways we could write a comparison of two quantities. So in this case, I'm comparing the quantities 5 and 8. So one way to do it is just with words. I could say 5 to 8, 5 to 8. Another way to write it is with a colon, as you can see over here, 5 to 8. That's also how I read that, 5 to 8. And the last way and the most common way is write it as a fraction. And it's the same thing, we read it as 5 to 8. Right? And I mean, you could have it flip-flop depending on how you want it worded, and especially when you set up your proportion, you always want it the same way. But really, it means division, you know, if I think of it mathematically, because it's written as a fraction. And if you notice this fraction over here, 25 to 40, that's the exact same thing, isn't it? Because if I actually simplified that, I could divide both by 5, and I would get 5 eighths, 5 to 8. So that is the exact same ratio as 5 to 8, okay? So just make sure to always simplify your ratios as you go. It's always very helpful. And then here, if I actually divide them, I'd get 0.625. So we're going to be looking at all kinds of sorts of ways of our ratios. So it's good when we work with proportions and work with ratios that we know how to switch between fractions and decimals. Okay, and you've learned in the past, if you want to change a fraction to a decimal, you basically just divide. You take the top divided by the bottom. I'm going to pop up my calculator. If you have a graphing calculator, great. This would be perfect. If you have a scientific, I'll kind of give you a brief description of that as well. So for a graphing calculator, I'm going to type in 7 divided by 11. Just like it says. Boom, there we go. I got a decimal. Okay, so how would I write that? 0.63, 63, 63, 63. And why is there a 4 at the end? Well, does it actually stop there, or does it keep repeating at 63, 63, 63? Yeah, it should keep repeating. This guy is 0.63 repeating with a bar notation, right? That 4 is rounded, because if you think about your calculator, it can't fit any more numbers, so it's going to stop and round it. So it would have been 3, 6, so it took that 6 and rounded the 3 up to 4. That's where you got that 4. Okay, well, let's say I had this decimal, and I wanted the fraction. I didn't know what the fraction was. Okay, what you can do is, I could type that fraction in again, or that decimal in, and I go 63, 63, 63, 63. I could do it a bunch of times. And then I want to convert that to a fraction. So if I have my decimal, I want to convert it to a fraction. There's this math button over here. You just go ahead and click on your math button, and now you have two options. You have change to a fraction, and you have change to a decimal. Well, I want to change it to a fraction, so I'm going to select that. I'm going to hit enter. And I'm going to change it to a fraction. Oh, it didn't quite work out. So guess what? Anytime you have a repeating decimal, you're going to have to type it in a bunch of times. Now let's try it. Fraction. Boom, now it gave it to me. So earlier when it was 7 divided by 11, if I want to quickly just change that decimal to a fraction right away, we want to take this last answer and change it to a fraction. So I don't even have to hit anything. I can just leave this just as it is, and I can hit math, change to a fraction, enter, and it'll automatically put my last answer and change it to a fraction. And that should work, 7/11. There you go. So you just have to be careful with the repeating decimals, but that should work for any decimal. And it works backwards too, right? If I want 7/11 to a decimal, math, go down, change to a decimal now, and there we go. So it works both ways. That's kind of the quickest way to do it. If you have a scientific calculator, you need to look for a button where right above it says F to D, F to D. And that'll change it from fraction to decimal and decimal to fraction, vice versa, okay? So look for that button. I can help you in class if need be. Well, let's think about this now. What is a repeating decimal? We just looked at one, right? It repeats, that pattern repeats over and over and over, right? If it's one digit repeating, the quick way to write that as a fraction is just put that number over 9. It's nice and easy. Well, if there's 2 digits repeating like this 0.63 up here, all we got to do is put those 2 digits over 2 nines. Because if I simplified that fraction, right, I would divide both by 9, and I would get 7/11. So that's kind of the quick trick on going back and forth with repeating. Some of the repeating ones are really tough to do, but those are the easy ones. What does it mean for a decimal to terminate? Well, that's if it doesn't repeat, it just ends for sure. So if I had like 1/4, that's really 0.25, and it terminates. There's nothing after that. Okay, and so those are actually in common. The repeating decimals and the decimals that terminate, we call those guys rational numbers, because a rational number, well, technically it says numbers that can be written as a ratio of two integers, which basically just means any number you can write as a fraction with integers. So for example, 0.25 I wrote as 1/4, right? I wrote it as a fraction. 0.7 repeating, I wrote as 7/9. 0.6 repeating, I wrote as 7/11. I was able to write all those as a fraction. Whole numbers, same thing. If I had the number 8, that's a rational number because I can write it over 1. That's as a fraction. So all those are rational numbers. Irrational numbers, we'll just look at one of these in general, is where your decimal never ends. So an irrational number would be like pi, right? Because that goes on forever. Or the square root of 5, because that's about 2 point, it just goes on forever and ever and ever. It's 2 point something, but it just never ends. Okay, so those are types of irrational numbers. If you can write it as a fraction, it is rational. All right, now let's get to our proportional thinking. Well, a proportion is basically taking two ratios or two fractions and setting them equal. Okay, so 1/2 equals 5/10, right? Those are two equivalent fractions. And just think, when this is set up, the 1 kind of matches with the 2 and the 5 with the 10. Same thing looking across. The 1 matches up with the 5 and the 2 with the 10. So if I kind of move things around, let's say I flip the 1/2 to 2/1. Well, the 2 matches with the 10, right? So the 10 would have to go on top and then the 5 on bottom. Those are still equal, right? 2/1 equals 10/5. That still equals. So that's good. Same thing. Let's say I wanted to put the 1 over either the 5 or the 10. Well, what would we say? The 1 matches up with the 5. So I could do that. But then, let's see, the 1 matches up with the 2. So the 2 would have to go on top. And the 5 matches up with the 10. So the 10 would go on bottom. Do those still equal? Yeah. So really, I can move numbers around. As long as you still kind of match up things, it works out. So the 1 always matches up with the 2. And the 1 also matches up with the 5, so it has to be consistent. So that worked down here. The 1 matched up with the 5, and the 1 matched up with the 2. Okay, so as long as it's consistent with your matching, that's kind of what you need to think of with your proportions, especially when you get to our story problems. So what if we're trying to solve a proportion? There's lots of ways we can do this. Okay, if you can just see it right away, just solve it. So for example, it says 2/3 equals x over 6. Well, if you can see, how did you get to 6? Never think of addition here. You're not adding. It's always in terms of like multiplying and dividing, right, when you simplify fractions. So really, we multiplied by 2 to get to 6. So what would you do for that top? You do the same thing, multiply by 2. So what would x equal? 4, right? And so, because if you had 4/6, that simplifies to 2/3. So if you can see it right away, just go ahead and solve. You don't need to go through the work. But there's going to be times where you can't tell right away. Okay, so what can we do? Well, the one method is what we call the cross product. So the cross product method is you take your proportion and you cross. Well, what does product mean? Yeah, it's multiply. It's the answer when you multiply. So we're going to cross multiply. So basically, I'm going to take the p times the 176. We're going to multiply it crossways. So p times 176, well, we write that as what? 176p equals, and then 12 times 132, 1584. So remember, cross products are equal to each other. And then to solve for p, well, what are we doing with p? We're multiplying by 176. So the inverse is to divide by 176. And whatever we do to one side, we do to the other. So p would equal 9. There we go. Another way we can look at it is, well, let's just rewrite this, is to simply solve it algebraically. So what are you doing to your variable? You're dividing by 12. So what's the inverse of dividing by 12? Multiply by 12. And whatever you do to one side, do to the other. Because what happens is when you do the inverse, it cancels, and you're just left with p on the left side, because it's really 12 over 1, and they cross cancel, and p over 1 is just p. And then over here, 132 times 1, or divided by 176 times 12. Remember, when you type this into your calculator, to put all division or all fractions in parentheses. 132 divided by 176. And then times 12. There we go, 9. So P equals 9. That worked out as well. Well, let's just say the variable was on the bottom. What if it was 12 over P equals 176 over 132? Okay, and you really like this middle method right here. You like doing this method, just multiplying what it is. Well, all you have to do is get the variable on top. So I could just flip-flop. I could flip these two around as long as I do what? Flip these two around. So I could rewrite this as P over 12 equals 132 over 176, and then just simply multiply by 12. Okay? So any method, cross product or algebraically, is just fine. Just make sure if the variable is on the bottom, just like it was over here, to flip-flop. With story problems, the best advice is to read carefully and set up your proportions correctly. Okay? And to do that, you want to think of kind of like parts and wholes. That's really helpful. Okay? And I'll explain that here in a second. Let's look at our story problem. So it says, Jen estimates that 3 out of every 5 students will attend the class party. She knows that there are 175 students in her class. How many people will attend the party? Anytime you have things that relate with like parts and wholes, you can set up a proportion. So I can set a fraction equal to another fraction. So now let's go back up and look. It says 3 out of every 5 students will attend the class party. So think, which one's the part, which one's the whole? Yeah, 3 is the part and 5 is the whole. So when I write that as my first ratio, 3 to 5, just think the part is on top, the whole is on bottom. So that has to match up when you do your second fraction. So now it says she knows that there's 175 students. So where does that 175 go? Is that the part or the whole? Well, that's in her entire class, so that is the whole or the total. So that has to go what? On the bottom here. So 175 must go on the bottom. So now I know I don't know the top, so I just give it a variable. I'll just give it x, and now you can solve however you'd like. If you do it algebraically, you can just multiply by 175 on both sides. If you like the cross product, I could take 5 times x, which is 5x, and set it equal to 3 times 175, 525. So either way works just fine. So if I look at it algebraically, 3/5 times 175 would give us, well, and remember that's really like 175 over 1. I could rewrite it. So I'm going to cross cancel 5 and divide 175 by 5, and I would get 35, and 35 times 3 is 105. Same thing if I went over here. If I solve my cross product, divide by 5, x equals 105. Same thing. And then we always make sure that we have a label. So 105 students. And there we go. So like I said, just be very careful with setting it up. Think of like parts and wholes. That's kind of my best advice.